to take preschool, but I taught maybe one at a time. Shut up. I would.
Oh my god.
Not really. Yeah, I think so. Okay.
All right. Here we go. All right. Let's for a little review here. Let's have everybody work in a group here maybe and do this problem. Be a good review of some of the things I want you to be able to do with parametrics for the quiz. Okay? On your the quiz is all calculator. Okay? So be able to draw a graph of this. Parametric, right? On Quiz Monday. Parametric equation, be able to graph it, be able to sketch it, be able to trace on it, be able to plot points on it. Okay? Be able to use the equations, both the speed, the slope type equations. Those kind of things.
So is this like the Luke Skywalker thing?
Well, the Luke
A little bit
Skywalker,
easier,
it's from the
probably.
Luke Skywalker in the sense that it is a parametric equation. Luke Skywalker was more difficult in that Shanghai aspect of it where we had to do the two equations kind of thing. The quiz is going to be more straightforward. It's going to be more straightforward as far as using the formulas and stuff like that. So if you can do a lot of these things that are on here, or do these things that are on here, this wouldn't be totally inclusive of it, but and be able to trace and graph and sketch it and all that stuff and answer these questions. That's most of the ideas on parametric right in one problem. This would be the one with a pitch. This would be like a pitch being thrown from the pitcher's mound. The pitcher's mound would be at 0. The plate is 60.5 feet away, right? We did a problem very similar to this in class. It's being thrown from a height of 7 feet. Okay, horizontally at 150 feet per second, right? But on the quiz, I'm going to give you the equation. And then you've also got that arrow problem that I handed out to you yesterday would be another one that's, very similar kind of thing. Yeah.
This is no air resistance,
Right, this was the old no wind resistance kind of situation.
Mr. Parker really likes the pun on the Star Wars sheet, top corner, flying off on a tangent.
Thank you. No one said that the other day.
Brown noser. So what did you say? This is feet per second. Maybe we should just zoom.
Feet, yeah, this is feet and seconds. Feet and seconds.
I'm on it.
Remember, X is 0 at the pitcher's mound. X is 0 at the pitcher's mound. X is 60.5 at the plate. Right? Those were the distances we used in this example. So that would have been given to you in the problem.
Step your game up, bro. I was just concerned with what you were doing. It's so wrong.
Well, the horizontal velocity is x prime. Remember, we said there's no wind resistance, so that's the only thing that would slow it down horizontally.
Wait, so A is just
She's like, it was so smoky every time. I got some.
it's just X prime. They just take the since there's no way resistance, it's just gonna stay the same.
It's like also a
So what kind of world is this? Oh yeah. Mr. Clark, is there necessarily units on the first one?
Sure. No, it's velocity. On which one? On A? It's velocity. Would be feet.
Wouldn't see how far.
On A?
I can tell by the computer.
On A, it says find the horizontal velocity of the ball. Velocity. So it's,
So then B, find the speed of the ball quarter second after the race. Won't that be like 150 feet per second?
no, we have an equation for speed
Oh,
on a parametric thing. Now remember, with parametric equations, horizontal velocity is just what? In a parametric equation, what's horizontal velocity? It's not x. X prime. It's just x prime. And the vertical velocity is y prime. But the speed of the particle is that equation. No. Not, it's that equation. We have an equation for the speed of the object. Speed of the object's in 2 dimensions. It has both horizontal and vertical. Right? You need to know those equations, right? You need to know those equations from the note. The speed equation, speed of the particle on the path. Here the particle's the ball. And then the slope of the path, right? The slope of the path. You need to know those equations. Yes, for sure.
So that's so the path is.
What's on top and what's on bottom whenever you do slope?
Or I mean y prime.
Try trace at 40.5.
Okay.
That.
When you do that, Well, it's T. When you trace, it's T. T is time. When you trace in a parametric equation, you're tracing T, not X.
Wait, on part C, what
X is the horizontal distance, Y is the vertical distance of the ball, but T is the time that the ball is at those places.
What are we saying?
So yeah, you've got to solve an equation. You can't just trace.
What are we saying?
60.5.
60.
Yeah. Yeah.
How do you find
And-
the T?
Well, I'm not sure that's going to trace. I will see where it is.
Oh.
To get it.
That makes a lot more sense.
That's
Oh. So did you guys get like, you get some point oh five for the for the T? T is 125. Or not for the T,
Why five?
for B. Is that what you said?
Oh, because you're like, you have to swear.
Oh, wait. Gosh, I don't even know what I'm doing right now. You just keep working, so just don't pay attention.
The speed equation is x squared plus x minus squared. Plus one times j. You just take that. 150.21 d3 squared minus 32 squared. So you have t squared. Negative 32. So you can put me is negative 2. And that's you might be appropriate.
Wait.
But since it's inside force, it's 32. Negative 1 squared. Positive 6. It's my arithmetic. It's my arithmetic. What you get for
So it's-
negative 10576.
I'm mad at it all.
I'll do it this way.
Yeah,
to see if
I'm
I
ready
can
to
see
really
it.
on that one.
I find mine can't. Well,
Now remember, when you trace, listen, when you trace on a parametric graph, you're tracing T values.
oh yeah, not
Time, right? Not X and Y. I mean, it gives you X and Y.
Like we could. Well, mine goes to 19.5 or 21.
Yeah, you can't do it by tracing. You've got to do it
Yeah,
by
but
solving.
you have to do it 20 feet from home plate, so it'd really be 40. You're looking for 45.
Or is it 20 feet?
It's just this class too.
Although, Jake, it says horizontally, so why would you be using Y?
We need to do both.
We have to do both.
Yep, we definitely do. I want to do both.
I don't know.
If you had the right idea, you were using the right equation.
I thought, for some reason, I thought it was everybody.
Because from home plate.
Why the 45?
Because 0 is the pitcher's
This is so close.
60.5 is home plate. So 20 feet from home plate.
Plus. Because that's a negative number. So, and then you take the derivative of that,
The slope
which is
y prime
negative
over x
32t. And you plug in
Now we have to do
5 to t, which 1/2. So it's t. T. Negative 1.05.
Oh, you just crushed right there. That was such a crunch. I bet he's not even expecting.
I think it's
Is he?
what I always want to do.
All right, how we doing? Did we get almost there? Okay.
Negative 0.056. On what? You need salt. So x is 40.5. Negative y. X is negative 60. Oh my god. Maybe that after you solve it.
Sucks.
And often on these parametric equations, T is the kind of the key ingredient here, the time, because that is your input, to these things. And so, as some of you were figuring out there on this last one especially, so the 20 feet horizontally, that's an X value, right? Now it turns out it's actually 40.5, right? Because zero is the pitcher's mound, 60.5 is home plate. So if you come back 20 feet, you're at 40.5, right? So X is 40.5, but that goes there, right? That goes as an output. X and Y are outputs in a parametric equation, right? And T is the input. So you're solving an equation. You can't trace to do that anyway. And that's not acceptable anyway, to trace on something. You really need to, on a graph, you really need to set it up as an equation that you're solving or whatever. So you put the 40.5 there and solve, right? And that could be a Y. They could have said instead of this, when it's 20 feet from home plate, they might have said when it's, 3 feet off the ground, right? If they just said, if this same question, find the slope of the path when it's 3 feet off the ground, then you'd have put a 3 in for Y, right? And solved that and found that time. Okay, so you got to know where to plug them for what things stand for. All right, so here's what we got for the answers. Okay, horizontal velocity. Now the 3 feet off the ground turns out we didn't even need, right? Because the horizontal velocity is constant in this problem. It's x prime, which is just 150. And we talked about that because if there's no wind, that's when Zach asked about the wind resistance, was because of that, right? We talked about that. If you throw it at 150 feet per second horizontally, which was what this situation was, and there's no air resistance, there's nothing to slow it down horizontally. So it will continue to go 150 feet per second horizontally. Then gravity starts pulling it down. That's where this part of the equation comes from. And so when we answer part B, what's the speed of the ball later? It's actually speeding up, which is not realistic. But 150 feet per second this way, plus gravity pulling it down, is going to actually speed it up just a little bit. So it's not unusual that the speed ends up being a little more than 150. But the speed equation, remember, is x prime squared plus y prime squared, right? And that was from our notes the other day. Yeah, it's x prime squared plus y prime squared, and then the square root of all that. Okay, so you come up with that number. And then, like we were talking about here, you take your x equation and set it equal to 40.5. So you get t equals 0.27, and then your slope formula was y prime over x prime. Put your 0.27 into it. And think about it. The ball is, he releases it horizontal, and it's just gradually dropping. So it's a very slight slope, almost a zero slope, but just a little bit negative. And so that makes perfect sense that the slope would be something like that. Okay? So, those are some of the things, those are kind of the basic things. Use the two formulas that we need to know with parametrics. Okay? All right, so that's one of the things, one of the big things that's on the quiz. The other thing would be the optimization. So there was our notes from parametric here. If we go to the next page, then we had some notes on optimization. Any in the Anton packet, the new packet from yesterday that you want to, do you have a copy of that? The optimization, which would have been the last couple of pages in that packet. Are there, number 14, was that the circle and the square? Yeah, that's a good one. What I like about 14 is the endpoint is a really important part of this. We've had a lot of optimization problems where the endpoint was essentially not really there. We didn't have to think about it, or it was infinite. We had to think about it, but it was really the opposite. Like we were trying to maximize volume, but the endpoints were the zero volume, like the minimum. All right, so 14. We got a circle, we got a square. And we're going to take a piece of wire and make either just a circle or just a square or both. And what do we want to do here? We want to maximize and minimize the area that would be formed. Okay, so max or min, but everything would start the same. We just, if we do a list of candidates, we'll just kind of kill two birds with one stone. Okay, so what is my area equation? Yeah, for both combined. X, if I call this X and X, and obviously R here probably, so X squared plus pi R squared. So my thing I'm trying to maximize or minimize is that right there. Okay? Now, that's both of them combined. Now, if I only do a circle, then obviously X is 0, right? So that would be an endpoint, right? And if I only do a circle, or if I only do a square, then R is 0, right? And it depends when we talk about endpoints, which one's going to be my input variable. Am I going to do X or going to do R? Which one am I going to solve for? Well, we got a choice. We can do either one. It doesn't really matter. And I think I've got this worked out both ways somewhere. But how do you want to do this? What other information do we have here that can allow us to get this in one variable? The perimeter, right? The perimeter, I know, has to be the length of wire that I have, which is how much? 12 inches of wire. So what's the perimeter of a circle? 2 pi r plus 4x has to equal 12, right? I know that. All right, so now my choice is I either solve that for x and substitute it over there, or I sub for r. Now it's really not going to matter because either one I'm going to have to square. If I solve for r, I'm going to have to divide by a 2 pi. If I solve for x, you want to do that? Solve for x? I mean, that's fine. I think in the end it doesn't really matter. We get to use our calculators anyway, so if it gets messy, that'll be okay. So 12 minus 2 pi r, and then divide by 4. So that would be 3 minus what? 3 minus pi halves r, right? Because 2 divided by 4 would be half. So 3 minus pi halves r. So I can come over here and substitute that for my x. So I get 3 minus pi halves r squared plus pi r squared. Now I could FOIL that and do, oh wait, that's a, forgot my r. Okay. Or I could just type it into my calculator like that, right? So there's no real need to simplify that or anything. So there's what I'm trying to maximize or minimize. So I do what? Derivative with respect to r, right? Now this is not a related rate problem. We're not going to have r primes. We're not going to, right? We're not going to have r primes in there. We're not doing it with respect to t. We're doing it with respect to r. So the derivative of r would be dr, 1, right? The derivative of r is 1. There's no r prime situation here, okay? We're doing derivative with respect to r. All right, so a prime is, and go ahead and type that out.
These problems are going to say A prime is no.
Yeah, these are the ones where we have our 3 candidates, right? Our 3 candidates, derivative is 0, derivative is undefined, and endpoint. So whatever, I'm not going to write it down. You would write it down, okay? If we were doing this problem and it comes out, whatever the calculator tells you derivative is fine. You can write that down. It's something. And then we're going to do what with that? And we're also gonna check if it's ever undefined. My guess is it's not, cause it's not gonna have a bottom, or it's not gonna have a square root.
How do you do
What's that?
that? Check
To check if something's undefined is usually if you have a zero in the denominator, or you have a square root of a negative or something like that. Usually zero in the denominator is a big one. Okay? That's the one you normally look for. All right, so you go ahead and get your derivative. Now do a solve. Set it equal to 0 and solve it. And what do you get for r? You get pi over 8.
We got R equals 0.
Six over five.
Yo, one sec. I'm on it.
Oh, I see what I did. Okay.
Well, we'll go with the Democratic. Whichever one gets the most votes. We'll go.
Why did that error? Because you said you didn't set it equal to.
Yeah.
6 over pi plus 4.
Yeah.
Is that the only? Is there just one?
You didn't do the derivative.
6 over pi plus 4,
Relation to r.
which is the same as what? Point 8401 something.
Yeah. There it
Now
is.
solve that. Set that equal to 0. Do a solve. So this would be a good one for list of candidates. Now let's talk about endpoints here a little bit. Okay. Now what variable are we looking at when we talk about endpoints here? Looking at r, right? Because r is our input, so we're asking ourselves what's the littlest r could be? So what's the littlest r could be? 0. If r is 0, what's that mean? No circle. If r is 0, there's no circle, means we used everything for the square, all the wire for the square. Okay? Which is a legitimate situation. And what's the biggest r could be? When we don't use any here, right? So I would come back to this, right? I would come back to this, because we only have 12 inches of wire, right? If we use it all for the circle, then it'd be 12 divided by 2 pi, 6 over pi, right? You have to make sure and put the 2 pi all in parentheses when you divide it. But does that make sense? Okay? If x is going to be 0, then 2 pi r is going to have to equal 12. Our circumference, here we're going to use all the wire for the circle. So circumference will have to be 12. So 2 pi r will equal 12, so r will be 12 over 2 pi, which would be 6 over pi. So the biggest r could be is 6 over pi, which is 2 point or 1 point something, 1.8, 1.9, somewhere in there probably. Okay? So our list of candidates, we plug back into our area equation. So either r is going to be a 0, r is going to be a 6 over pi, whatever that is a decimal, or r is going to be our stationary point, which was 6 over pi plus 4. Now we could do our vertical bar if you want, right? We could come back to our A equation here. We could type that in, do vertical bar. Remember how we did that? Did our vertical bar and let r equal 0, let r equals, did the curly brackets, however you want to do it. But you basically have to take those numbers and plug them back in for r. Let's do decimals on our answer because it's a lot easier to compare. I can do 0. That's just 9, right? Because if we don't, if R is 0, we're just doing the square. If we had 12 inches of wire, it'd be 3 on the side. 3 times 3 is 9.
Right.
So what do we get for 6 over pi as a decimal? 459. Is that the other one?
No, that's right, that's right.
Okay. And then this one? Okay. So a little bit surprising, right? Our max is when we did what? Well, maybe it's not surprising. All circle. You know, and we were talking about that when we were doing the farm one with the fence, and you know, we got a square, right? I mean, that's, if you want to do a rectangular shape for a given perimeter to maximize your space, your area, right? If you wanted to build a cattle pen and for the same amount of fence hold the most space, it would always be a square. You always do a square. Now you have other issues that might play into that, but it would be a square. That's the most efficient way. But if you weren't restricting it to a sided figure, it'd be a circle, right? For the given amount of fencing, you would build your cattle pen in a circle. That's what would give you the most space. And that's what happens here, okay? Because we have a fixed perimeter. So the best way to do it the most space would be to do it all as a circle. And then the minimum, the one in between where you did part circle, part square, that's actually the least amount of area. Okay?
Do we have to put all these problems like in one place, per se?
What do you mean?
We don't have to turn.
No, yeah. If you're doing your work, if you do it in the packet, it's just homework. We're not going to turn those packets in. Those sample packets, those thick ones, we'll be turning those in. You have room to work there. Okay, so there you go. That's just a good optimization problem with list of candidates and that kind of thing. Okay, that's the process. All right. Then the other thing we've got is related rates. Is there one in the Anton packet you would like to look at here?
Okay, let's do like, can you do number, for some reason I kept getting something different from what you had for number 10.
What was number 10?
I mean, it wasn't like a hard one, but I just kept getting different.
Is that the one with the clock? Or?
No, it's the one with the balloon.
I won't ask
A spherical balloon is inflated so that its volume is increasing at a rate of 3 cubic feet per minute. How fast is the diameter of the balloon increasing to a radius of 1 foot?
So the volume of a sphere is 4/3 pi r cubed.
Right.
Nice thing there is they're just one variable, really. So the v prime, so when you bring the 3 down in front, you get pi r squared r prime, right? So these are the types of problems where we have to tack on, because now we're doing the derivative with respect to t. This is like dv dt, dr dt, right? Doing implicit differentiation. And they said what now? What did they give me?
How fast is the diameter of the balloon increasing when the radius is 1 foot?
Okay, they want to know the diameter when the radius is 1. So the key,
Yeah.
V prime is
and they also tell you that that's 3,
Yeah.
and the balloon's increasing, so that's the other thing you really got to make sure you take care of here, is these primes, if they're positive or negative. Okay, so if something's increasing, I kind of missed having combs around, because I kind of missed these little conversations going on while I'm talking. I'm being facetious. All right. So the what I was saying was, you got to listen on the primes. If it's increasing or decreasing, then decreasing is negative, and they won't tell you that in the problem, right? They'll just say decreasing at 3, whatever, and you have to remember to put a negative in there. Now, the other thing you can do is, if you know on your answer, if the answer, the answer is how fast is the diameter increasing, right? Then you know your answer better be positive. So if you get a negative, you know you probably had a sign wrong somewhere, right? So you can sometimes fix that in your answer just knowing what you're supposed to be getting. Now, sometimes a problem just says how fast is the diameter changing, right? and they don't tell you, whether it's gonna be increasing or decreasing, so, and I'm glad I just mentioned that, just reminded me of something. When you give your answer, you've gotta ask the question that's asked, so if they say, how fast is the diameter changing? And let's say you get the answer to be -2. How are you gonna answer that question? If you just write -2 feet per second, you'll be fine, right? If it came out negative, just write -2 feet per second, you're fine. But some people like to give a more full answer, and I like that, and then write it out. Would you say that it's decreasing at -2 feet per second?
No.
No, right? Because that's like a double negative, and technically then you're saying it's increasing, right? So you would say it's changing at -2 feet per second, or you would just say it's decreasing at 2 feet per second. Does that make sense?
Or it's increasing by
Or it's increasing at a negative, yeah, I mean, not to get too overboard with that, but just think about what you're saying if you are gonna write that out. But it would be okay to just write -2 feet per second, and that answers the question typically. But small thing, but it is something to think about. All right, basically we gotta get D involved here, and it would just be this. Diameter is 2R, so D prime is 2R prime, right? So we could go ahead and just find R prime here. So we can take our V prime is 3. We can take our R is 1 and find R prime. So the 1 doesn't really matter. So we get 3 over 4 pi equals R prime. So then D prime would just be 2 times that. So 2 times that would be 2 would cancel that, and that'd be 3 over 2 pi. And then we should put units. So it'd be 3 over 2 pi. Give a decimal if you want, but this is okay. If you give a decimal, give 3 decimal places, but this is fine to leave. And then what would be units? Inches? So feet per minute. Now again, think about what the units would be. It's diameter. So diameter is going to be in feet. Volume is in cubic feet. Area would be in square feet, right? So make your units match what it should be. Now, if you want to put your units through there, you can see why it would be that, because remember, this over here is inches cubed, right? Or feet cubed. This over here is feet cubed, but the 1 is feet. So then you square it, so this is feet squared. So over here you got feet cubed, you divide by feet squared, that's why you end up with feet. And the 4 pi is just doesn't have a unit. So that's why that ends up in feet. But, I mean, I don't think you need to think it through. If you did everything correctly, then just put the units on that match what it is you're finding. If you're finding area, it should be inches squared or squared. If it's volume, it should be cubed. And if it's a distance, then it should just be regular feet or inches. Okay? So there you go. Now, the reminder on the cone problems, I think that's a key thing because cone is a very usual problem, typical problem that we get. Where you guys go? Tough meat.
We have the Russell Swim party in Beaumont. Scott, they're
Oh, yeah, they're always
They have a number 113 all class.
all right. Good luck, guys. Basically, it's just hey guys, Jake, work on the package, study for the quiz, whatever, and then on the sample packets, like the sample one, be a good idea to maybe get into the free response and try to get those going. But that'll be after the quiz Monday too. We'll talk about that. All right. Good luck. This isn't a number at all. I don't know. Was there a cone one in the packet that you wanted to do, or
I just kind of want to do 25, just because
that's a different one? Is that a?
it's a related rate problem.
But it's not a
But
cone.
it's not.
Let me just make a comment again. Yes.
Oh, well, I was gonna ask if you could just give us a list of all the formulas that we should know.
Ooh,
Yeah.
that's good.
Yeah. Like this, this one, we've done enough. You should, but I'll probably give that to you. Surface area we talked about, right?
Yeah, if you could just make a list of all.
Yeah,
the
I
formulas.
will. Yeah, let me think about that. It's after we do this, and then I'll do that. That would, sure.
That's
All right.
volume for.
Here's the key on this one, is on a cone, we typically do not want to leave both R and H in there, because then you have to do a product rule. Now, sometimes you do a product rule. We did those rectangle problems. Matter of fact, your first one there was an area problem. If you have area equals X times Y, and I tell you how fast X is changing, how fast Y is changing, X prime, Y prime, we would do a product rule here, right? So you would do a product rule. So you'd have X prime Y plus X, Y prime. I mean, we do that, right, on some problems. Cone, typically not, right? And the reason is this similar triangle idea. Okay, so if I know that this cone is 4 and this is 10, right, then I know that the radius to height ratio in that cone is always going to be that. And so I know that R is going to be, what, 2/5 H. And so I can plug that in right there, all right? And so when I know that, so if I know the size of the cone, then that can help me do this thing here. Now, sometimes it's easier than that, right? We've done problems where they just say, hey, the radius equals the height. Well, then you can just let R equal H and substitute, then it's really easy. But sometimes just give you the size of the cone, you can write this ratio, you can substitute that in, and now you can get your V in terms of just H's. And simplify it, right? Don't leave it as H squared and H, make it H cubed, multiply it together, and then you can get your V primes and H primes, and then you can answer the cone type questions, okay? So we've done several of those, but I just wanted to throw that up there as a reminder one more time. Okay, number, what'd you say?
I'm
20,
25 because just that's some trade.
what was that one?
It says an aircraft is climbing at a 30-degree angle to the horizontal. How fast is the aircraft gaining altitude if its speed is 500 miles per hour? But it's not necessarily.
Okay. And so it says how fast is what?
The aircraft gaining altitude.
So that would be Y. So it's asking for Y prime,
Yeah.
right? Yes, good. So it's asking for Y prime. So as this aircraft goes, this distance would be changing. I'm not sure we even need it. This distance would be changing, right? And so what does it give you?
It's traveling 500 miles per hour.
Okay, what would that be? Z prime. Now there is such a thing as airspeed and ground speed, right? Those are two different things. The airspeed would be this, and the ground speed would be this, right? So the more it's flying vertically, the less its ground speed would be, and so forth, right? But does it use those terms? I don't think it does. So if it just says its speed, that would be its airspeed. So that's going to be the Z prime. Yes. Because we always use radian.
Ooh.
I hate degrees. Degrees are stupid.
Why is radians better than degrees?
Oh, don't get me started.
No one's getting started.
Yeah.
Yeah,
Almost
Combs doesn't
any-
believe me
Almost
that-
any formula you have to use
that all
is
the
simpler
numbers add up
using
to
radians
infinity.
and degrees.
Yeah, see, that doesn't make sense to me.
Okay. Combs doesn't believe that all the numbers up to infinity equal -112 still.
Oh, should we watch the video?
Oh,
No, we should watch it again, but
yeah, that's a hard
Tell
to
me where I
get your
can
head
find
around.
the video.
Is that what you guys talk about when you hang out?
Yeah. Math? Always, every time.
All right, what else? They got to give you something else, right? Or not? Is that it?
So we did.
You talking about
That's all they give you.
science?
Okay. Case, pay attention. You asked about this. Here I'm talking about it. You ain't paying attention. Come on, Combs. You can be back here a half an hour. You're probably
Mind
gone.
blowing.
yeah, it's fine.
All right, so Z prime is 500. That's all they give you. They want Y prime. So they don't give you anything about X. Okay, so the next step is write an equation that relates your variable. Okay, so what do we want to write? What equation?
That's the part I was wondering about.
Well,
Sign.
yeah, we want to use a sine equation because we don't want to involve X. We don't want a Pythagorean theorem. What we want to do is something that involves these two because that's all we know. So we want to involve Y and Z. Well, what kind of equation would involve Y and Z? It's opposite over hypotenuse, which is sine. So the sine of pi 6, right? I mean, you can use 30 degrees if you want. And on your calculator, you can do degrees without getting out of radian mode there is a degree symbol in one of those menus somewhere.
Pie button.
The little pi button, yeah. The little pi button. So you can type in sine 30 and put a degree symbol on it, and then that'll override the radian mode that you're in. Okay, so you can do that. So that would have been okay if you didn't change it to this.
Just us, like.
Oh, that could be helpful for physics too. I suppose I didn't think about that. Although the problem, if you solve an equation, like an inverse sign, if you do an inverse sign, it's always going to give you radians. So you'd have to change the mode there. Anyway, so sine of pi 6 would be y over z. So now what do? Derivative of both sides. Well, what's sine of pi 6? What's a derivative of sine of pi 6? 0. The derivative of sine of pi 1. Right? This is a half. This is a half. Maybe you're better off doing this, right? That's a constant, sine of pi 6. All right? Now, if this would, we've done some problems. We talked about something yesterday where this is theta. We didn't know this, right? So this, if this was sine theta, then this would be cosine theta, theta prime, right? But that'd be if your angle was changing, right? If you had a searchlight or something going up or something
Or
like
a
that.
clock.
Or a clock or something like that. Then you need a theta prime. But that's just a number. That's a constant. Okay, so we get 0. Okay,
0?
I haven't done the derivative yet. I just
I
wrote that.
thought you meant the derivative.
So what's
of
it-
pi over 6 is 1/2.
No.
Yeah.
I haven't done a derivative yet. All I did was substitution.
Okay.
Right? Sine of pi 6 is a half. Y over z. So now I'm doing the derivative. So the derivative of this side is 0. Derivative of this side is y prime z minus yz prime over z squared. Okay? And I'm looking for y prime. Okay, so what do I plug in for these other numbers? They give me some other stuff? They give me nothing else. Oh,
Yeah, that's just great, isn't it?
well, yeah, because that's probably more information we need because this is constant going here. So what's going to happen is this has got to be a constant no matter what. Clark, go ahead with what you said. What's the proportion? This is 25. Yes. Go ahead. Wait. Okay, and you got that from pi over. Sine of pi over 6. Which comes back to that, isn't it? What? Go ahead, Megan, with what you were going to say.
Well, can't you just multiply both sides by z so that you don't have to do awful derivatives?
Oh, yeah, but okay. So like right here, you could get y equals 1/2 z, because one of the things we talked about is like on that Pythagorean theorem one, if you solve for one of the variables, you get a square root, and that actually makes it an awful derivative. In this case, you're better off solving so it's not an awful derivative, right? So what happens on this one when we do the derivative, what do we got?
Y prime equals 1/2 z prime.
1/2
So it's doing
z prime, right? So a simple thing as taking this,
Ah!
and that's what I'm going back to. Now I'm not sure you had pies and stuff in there. I thought. Did you get 250? Oh, yeah, I think it's 250. Yeah, that's what I was saying. If we go back to this one, because I think you had the pi over 6. That's the difference. Pi over 6 is almost a half, but it's not quite a half. You see what I mean? So so it should have been pi over 6 equals y over z. Isn't that what you said?
Yeah.
It should have been 1/2 equals y over z. It's sine of pi over 6. Okay, and then we get this, and it's 250. See, because what's happening here is these numbers don't really matter. In other words, it's going to be a constant. Y prime is going to be the same no matter where the plane
guess
is.
what I was thinking was that you needed to think about it as a 30, 60, 90 triangle and then set up your proportions that way.
Yeah, that's what I was
Yeah, does that make sense?
Yeah, this is a 30, so this would be in a proportion of 1/2 to 1 to root 3 over 2, that kind of thing.
Yeah.
You're doing that sort of thing. Well, that is true, right? Look what we just said here. Y is equal to 1/2 Z. So it's the same thing. Yeah. Yeah. And here's another thing. Here's another thing that's true on these triangle scenarios, and this goes to a physics vector thing. Not only is X, Y, and Z going to be in this Pythagorean theorem ratio and those things, but so is X prime, Y prime, and Z prime. As a matter of fact, on the arrow problem, when I drew my picture on the arrow when it starts off. Now it's actually going to, the arrow's going to do this in a parabolic form. But as far as vectors go, it starts off initially, right here. So that'd be like the tangent, the vector. Well, that's how I drew it here. I had X prime here and I had Y prime here, right? And then this was the speed of the arrow, the Z prime. Well, that'd be the same thing. This is like that. So you could have went X prime, Y prime, Z prime. Same thing. Okay, and so we could have done this equation as sine of pi over 6 equals Y prime over Z prime. Seems kind of weird if you say, God, you do have your product there. Yeah, well, technically. But in this problem, because of the way that works, it is actually the same as Y prime over Z prime. So we'd have had this, so you notice how we'd have gotten the same thing there too as well. So that gets into kind of some vector stuff and physics stuff and so forth. So, but I like what you said right there is instead of going with that derivative there, why not solve for Y and make it easy? So it is 250. It is in that relationship. Okay? All right. And it is funny that the related rate problems are almost harder when there's less information.
Yeah.
When you read it, it's like, oh, that's pretty easy. There's not much stuff. The ones that got all these different numbers in them, you're like, oh my gosh. But actually, those are better because when you set up your equation, you got a lot of stuff to plug in.
Yeah.
Right? Every variable's got something to go in. And then you're done. All right, let's go ahead and just give you some work time on that. Basically, our assignment is going to be for Monday, and then even after the quiz on Monday for into Tuesday. Obviously, review for the quiz. Let me write down some equations here, like Megan was asking here. We'll do that here in a sec. But review for the quiz, and then finish sample 1, which basically should mean the free response. I mean, I'd already assigned for you to finish the multiple choice. Now, there's probably still some you have questions on, and at some point next week we'll take part of a day to answer a few of those, but some of that may have to come outside of class, where you come in here and you get, this book, and you look up some of those things. Trent, you probably need one of those.
Yeah.
You didn't print them off from the website. All right. All right. So finish sample 1, which would mean the circled free responses, and then start sample 2. The more you get done, the less you might have to scramble towards the end of the semester exam. The more you get a chance to look into, the more, if we go over them, you've had a chance to think about it. And then I think the fact that you've thought about it a little bit and then we talk about it a little bit, I think that adds and helps. I think if you just sit there and watch me work a problem and you've never seen it and even looked at it and thought about it before, I don't think that soaks in nearly as well. So start on sample 2, which means the multiple choice. Just get started, get through dozen or so, half a dozen maybe, whatever. And I'm talking about by Tuesday, would be a good thing. So try to sketch out a little time this weekend, a little bit over Monday night as well to get going on that. All right, as far as the quiz goes for equations, I would say your parametrics, you need to know all those. And so those are the ones we just talked about, the speed equation, the slope equation, right? So those would be 2 to know. For sure. I'm trying to think what other formulas. Business, from the business scenario, profit is revenue minus cost, right? I think that's important.
We did a business plan.
What else did we have in the business? Oh, you need a business plan. What else did we have in the business?
Oh, your other big one is just the revenue.
The-
equals X times P.
Revenue was X times P, little p, and remember that all that was units times price per unit. So to me, that's more of just a common sense kind of thing. You know, that's more of a, hey, you know, here's what the price is for one. And then take that times how many you have. And usually X is the number of units, so it's units times price per unit, which, so I'm not sure that's
Do
something
we
to
have to know
memorize
that
necessarily.
like C bar equals?
Well, I'd
C
s-
over X?
Yeah, average cost. Average cost, I wouldn't give it to you as C bar, but I might use the word average cost. Average cost is the total cost, C divided by X, right? Average cost, or cost per unit. They labeled that C bar, right? I might just say, find the minimum average cost, you know. So that's cost divided by X. So that could be one. When it comes to these different shapes, like, I mean, I don't think, Megan, you mean for me to write down like area equals length times width on a rectangle, right, or anything like that. I mean, there are certain basic shapes. You know, if it's a Pythagorean theorem problem, you know, if it's a right triangle problem, you need to know x squared plus y squared equals z squared or whatever. If it's an area of a rectangle, area of a square. But if I give you any that gets into the cone or a
Like
surface area of a three-dimensional, yeah, I think we know a box is length times width times height, but I'd probably put that on there. If I have any doubt in my mind whether you should
Have
know
lots
this,
of doubt.
yeah, I'll put it on there. But you know, a rectangle, a circle, you know, those kind of things.
I can do
Um,
rectangles.
Those I would probably not be on there. But if it's a cone and some of those geometric shapes, I'll err on the side of putting them on there for you. Okay. So that's about all I could think of probably. Okay. All right. So the rest of the time you can just keep working on the maybe keep working on the Anton packet and those examples. Those are some those are some optimization and some related rate examples. The parametrics we kind of went through already. So. All right.
Are the other like questions on this one did you do?
The ones that aren't circled, you know, it's kind of a. Let me look at those. If you wanted a few extras, you know, some of them probably get into some stuff that would be more confusing than you'd want it to be. So if I was looking at the front of that package, 6 isn't bad. 6 would be probably a pretty basic one, so that'd be good practice. 8 isn't too bad. 12 is the old ladder situation. It's probably a lot like 13. 21 was a cone. 22 is another cone if you want to practice that. 24 is another one like that that's not bad. Those are related rate ones. Optimization is a little harder to look at. 11's not bad. This is in the optimization side.
Oh, he just looked back at me.
Be more careful with where I look.
Yeah, it depends. Which problem you
I was looking at 42 there.
A little hostile.
That looks more like, kind of like a business one. I'm just trying to see if this is overly difficult. I don't think so.
fragile person.
Yeah, I think 42 is kind of like one of those, like the rent one, you know, that we did, the rent.
And
That might not be good. So, so let me write those.
I feel like we should.
Write those down.
We'll have a whole hour.
Page 274.
So, you said like how far? Was review for the quiz.
Basically, yeah. I mean, those were some, that's why I just tell those guys, some additional ones in the Anton packet that
It's not
aren't,
like a certain
that aren't
amount I
bad.
have to do.
no, I just whatever. I'm pretty much giving you all I can give you for the quiz. You may.